Hi, my name is Steve Cavaleris, and thank you for watching this episode of Tool Belt Workshop. If you found this on YouTube and you'd like to find more of these videos, just please go back to our website, which is toolbeltworkshop.com. Again, toolbeltworkshop.com. And then on the bottom here, we've got something called bonus channels, and we have a button for home automation. Now, we do these videos for free. So the way that we make money is that we build websites. So if you're a contractor out there, if you're a business owner, or if you just want to have a website where it says contractor resources in the middle, just click website, and then we will get back to you and we'll see if we can help you to build your website. So we hope you enjoy this video, and we look forward to doing a lot more. Thank you.
This is a home automation Quik Byte. We proudly present Relay Control. The digital recipe ingredients are a Raspberry Pi with power adapter, a light emitting diode, a 200 to 300 ohm resistor, connecting wire, a relay board, an SPST switch. See the description below for links to purchase any of these products that you don't have. Okay, so let's see how all this is connected. On the left, we have the Raspberry Pi. On top, we have a relay board. On the bottom, we have a breadboard. Now, these are all just the positive and negative connections. Let's start with that. Pin 2 is going to be our positive, and pin 30 is going to be our negative, which is connected along the bottom. All the negatives on the bottom, all the positives on the top rail. Plus 5 is on the relay is connected to the positive, and on the output, the normally open is connected to the positive as well. That wire should actually move down to the bottom rail. It's not connected correctly, and it's an easy mistake to make when working with breadboards because all the little connections are all so close together. So you got to be really careful about that. We're connecting that way because we're just going to connect LED, but you usually wouldn't do that. That's a completely separate circuit if you want, and the output can be connected up to 250 volts or AC or 30 volts DC, both doing 30 amps, which is quite a lot. So you can connect, a light bulb, you can connect a motor, you can connect a lot of different things as long as they don't go beyond the 30 amps and the voltages as I listed it on the top left corner. Okay, so what's next? Well, on the in pin of the relay board is connected to pin 12. The relay, and you're saying why we're using a board, not just a relay itself? Well, to power the relay on the input side takes a little more current than is available from the Raspberry Pi. So you would need a transistor, a diode, and a couple of things to properly work the relay input side. Okay. Here we have a switch that's connected to pin 40 and to 5 volts. We also have the LED, which is connected to the common, and then through the anode of the LED, and through the resistor, and then down to the ground. Let's analyze the relay control flow. So, first things first, to connect to node red, it's the Raspberry Pi address, HTTP Raspberry Pi address :1880. And you should see, well, you're not going to see this many flows. Yours is probably just say flow 1, and it'll probably be blank. But you could quickly fill it in so it looks like this, because it may look difficult at the moment, but we're going to describe and look at everything. So let's get started. Okay, so we have the address. You're here. And as we talked about previously, we've connected the relay to the Raspberry Pi. And the part here, this is pin 40. Representation of pin 40. You just drag it out from the filter nodes wherever you have your Raspberry Pi. I have mine here on the bottom, so you drag one of these out, you put it here, you choose pin 40, which I did as you look at the bottom. You'll also notice there's a down arrow, and that is here, meaning pull down transistor, so that when it's not connected to anything, the input is not sitting all over the place like you don't know what voltage it's at 0 because it's being pulled down to 0. So since we have the switch connected to 5 volts, when we press the switch, it turns the pin to 5 volts, which is a high. Now you can sort of see this at the moment, because as it goes out pin 40 and goes up here, at the moment it's connected to momentary function, and it's also connected to a toggle function. But the output going to pin 12 output, which is the in pin on the relay, is only connected to the momentary at the moment. But since it's connected through this to the toggle code is also working, and we'll be able to see it in action by the red and green status that are below the node. Okay. So let's, what did I want to do? Well, we can deploy. If you make a change, and that change is reflected by these little blue circles, like you see one here, 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 on my little comments. That means that code is not, there's something missing from that code, and really the next thing you should do to run it correctly is deploy it. So let's deploy. And now it's deploying. And when it's finished, then we're going to look at the node red function nodes. Function node is another node that you can use. It's what's called one of the core nodes, meaning that it's one of those nodes that you're going to be using a lot. And it's up near the top. So we go hold it near the top. And we can find it somewhere. Another cool way of finding things, like, oh boy, that's hard to find. If you press the control key and click on a blank area of the screen and let go, you can see that the same nodes to select are in this list. Which, okay, it's going to be just as hard to find it maybe on this list, but here you can actually search for it. So you would just search function, and then you can drag out a function node. Okay, but since we have it, we're not going to do that. Okay, so what I'm going to do at the moment, I think, is press the button, and I'm holding it in. So as you can see, the momentary is high because I'm connecting this pin to 5 volts, so it's high, and it's set to 1. And you can see the toggle, you can see both of them in action because you can see how the toggle works. It's also 1. Now I'm going to let go of the momentary, or let go of the switch on the breadboard. And now, as you can see, when I let go, the momentary goes back to 0. So we have a momentary switch. So if you need an action where the switch is momentary, the code is in here. And if you need an action where the code is toggle, I'm going to press it again. As you can see, it toggled. And the momentary just was on as when I was pressed the switch. So our current thing, what are we going to talk about, is the function node. So we're going to be as much talking about the relay as we're going to be talking about node red nodes, and we're going to add on to what we learned last time in episode 1. So what we're going to discuss this time, and the big player, is going to be the function node. which is what these are. Function nodes are probably the more complicated node in that it's not a configuration node. It's a node where you got to know JavaScript, or you got to be able to copy out JavaScript from somewhere and be able to use it in your flow. So you say, okay, we have two of them. Boy, is it different? Well, no. If we look here on the bottom, the momentary, right, is a pull-down switch connected to 5 volts, which both of them are. But the difference is that there's a message payload equals 1, which is not existent in the momentary, that it is existent in the toggle, and you'll be able to see it here in a second. So let's open it up. And there it is. So that's the code. And it looks, there's a bit to it, but it's not that bad. We're going to make it look simple. We're going to feel simple. Okay, we're going to go line by line through it. So the message payload equals 1 is right here on top. And there's a comment used for toggle, remove for momentary. So all I have to do is I can comment out this, and the last one on the bottom, and you get the same code that's in momentary. I just did it that way so that it's easy to show both of them, and just so that it makes it a little easier to look at. So what are we doing here? So the big thing we're learning, as well as the function node, is a little bit of JavaScript, a little bit of how Node-RED works. If you did any coding, hopefully you have some idea of JavaScript, because that's what makes Node-RED powerful. If you know, the more JavaScript you know, or at least know enough to copy and paste, that'll work for you in a long way. But it's not that hard if you know any kind of code. JavaScript is the same, probably, but the syntax is going to be a little different. That's usually what happens when you learn different. If you learn C++ and then you go to C#, it's not different. It's the syntax is different, and sometimes a couple of concepts, but usually very close. So we're going to go line by line, assuming that you have a little bit of JavaScript knowledge and a little bit of Node knowledge. So in a node, let's remind ourselves, a message comes into the toggle node. So then it goes through whatever you put in here to change the properties, and then you spit it out with this return message. So the simplest function node, all it has is a return message, which what we'll do is the message would go in and the message would go out. Nothing would happen to it. It would come just as it is. Now the message is the basic object used by, let's see what we can do here. Okay, let's see. Do we have something? We have nothing. Nothing or something out of toggle. Let's see if we can activate this. And here we go. Okay, so we activated this, and we got some kind of message over here that state equals 1. Let's try it again. And state equals 0. So where is this coming from? And what's going on? This is our debug panel. And this will give us messages that are returned, objects, all kinds of things. Let's actually get one of these going. I'm trying to get one that has doesn't have that's saying I want to show an object, and I'm not doing well with this. Is there no? Oh, there's no objects. Why is it not showing the object? No, because all these down. Okay, so this one. Oh, okay. Yes, okay. See, this stuff can get anybody at any time. So let's okay, just to show an object, then we'll explain that other stuff. Okay, so an object was passed through. In this case, it was an eject node with that says on or off, and it goes to these two things that do kind of this is what's called a change node, and these two do kind of a similar thing that what's going on up here in the function node. So, and then here, as you can see, we're sending out a complete message object, and we're going to show that, which is right here. Every message has an ID. Every message has a topic. It could be blank. So, and it has a payload. Excuse me. And so the topic is we're not using it, so it's just blank. The payload is false. And then we have this here called state is false. I created another property in this message object called state, and I'm passing the state of the relay into this object so that it can be sent across and we can see what the state is at any time. So at this point, everything is false. And if we do another one, it's false. Let's see, I think off. Yeah. Okay, because the toggle off makes on and on makes off. So here now everything, if you look at the bottom, everything is true. So the payload is true, the state is true. So we'll look at these in a second. So as we were saying, the message object goes through it. So when it comes in with all these things, topic, payload, state, you can work on them and then send it out. But in the case of a function node, you work on them by using JavaScript. So here it says if payload equals 1. Well, actually, pin 40 sends a 1, as you can see, a 1 or a 0. So if it's a 1, meaning that if it's high, 5 volts, you press the button, then the state, we create a variable, we call it state, we use flow.get. Oh, what's that? Flow.get is the memory of node-RED. It has 3 memories. It has internal memory, which is called context, which would be the memory is only within here, sometimes called local memory in other programming languages. It has global memory, whereby it would say, well, here it would say context.get if it was just inside here. If it says global.get, it's for any of the flows you have, you're keeping this information going. And if you have flow.get, that means the memory is only for this flow. So if I wrote state in another flow, it would be doing its own business even though it had the same name, because it's just in this flow. So you have flow.get the state. That's in memory. Now the first time around, you won't be able to get anything, because if you reboot the Raspberry Pi, you get nothing, because it doesn't hold the state. If you reboot, it's not going to work that way. So if it can't get the state because it rebooted probably or something, or a 0, so it's just going to assume the state equals 0. So you would see state equals 0. So it would think that the relay is 0 or low, not on. Now it could be on, and sometimes you press the button once, it doesn't work, you got to press it again just to get it going if the state is out of track. So what we did here is we said, okay, let's toggle this. And how we toggle this is that we take if the state is 3 equal sign is an is, 1 equal sign, it actually gives it the value. So you get the value, you say if it's 0, state equals 1. Let's set it to 1. which toggles it. And then we'll take node.status, which is the little status thing on the bottom, fill it with a nice green, put a dot, and put the text as 1. So you should see, like where it says toggle here, it's green, it has text.1. So you got to set all that up. It just doesn't know to do these things. If it's not else, which means if it's not 0, it must be a 1. So the state equals 0. Let's set it to 0, which then toggles it. And we fill the status with red and a 0, which is shown in just below momentary. It looks like that. Then, once you've done that, you take the state and you set it, which means you memorize it. Memorize the state within this flow. So if any other node in this flow goes looking at the state, it will know whether the relay is on or off. This is a nice way to do it, because if you're setting it from somewhere else, you don't want to press it. It thinks it's on, but it's not on. So it just doesn't do anything, and then you got to press it again. And it just doesn't seem to work well, even though it's doing the right thing. Doing it with the memory is so much a better way. Now, it wouldn't matter if this was the only way you're doing it. You're pressing the button, you're not doing it. But if there's another way, like we're doing, we've got another way to toggle. This is a good way to keep those two in the proper state. Okay. Next, we're debugging the state into the debugger window. So node.warn. We saw it before. It said warning, and it said state equals 1. State equals whatever the state is, 0 or 1. We saw it before while I was noodling around with the trying to show you an object. And then we're going to take message payload, which is our basic bread and butter property, and we're setting it to state. So whether it's 0 or 1, we put it into payload, and we're going to pass it on. Because we've got to pass it on onto the Raspberry Pi, right? And return message, then sends it out, and that's the end of it. And then it would go out, go out to pin 12, and it would be a 1 at pin 12, and then pin 12 knows to go high, and then that would turn on whatever it is you're going to control, from an LED all the way up to some regular light bulbs or whatever you have with high voltage. If you are trying to do something with high voltage, please be careful. There are other ways to do it than trying to do it with just a relay with open wires, because that voltage will hurt you. So this is better, and in automation we've seen this used more for 12-volt fans, gates, gate control, so you can turn open and close the gate in the front of the house. Things of that nature. Usually never do anything with high voltage in this way, because it can be dangerous. Okay. The momentary is the same. It just doesn't have that if equals 1 that makes it go on and off. This is when you press it, it gets a state, it gives it the state, and then when you let go, it's a whole other thing, and it removes the state, and it goes forward. It's like two messages being pressed, one to push in, and one for the release. So they're very similar that way. Actually, in this one, I just noticed. I noticed an error. Do you see what the error is? What's the difference between this one and this one? This is flow.set. We're doing a flow level. And here, we're doing context.set, which means it's just within this module. The other module will know nothing about the state. Maybe that's what's making it work, not knowing anything about the state. That's kind of nutty. Probably do this and it won't work, I bet you. Yeah. So this is flow.get. Nothing here. What is that? Done. Oops. What's that, a blue circle? Remember what that is? Yep, it means I changed something here. And in order for it to work, I have to deploy. So let's deploy. See, anyone can make mistakes doing code. It's a matter of how you debug, so that you can find where the problems are, solve them, and get it working as fast as you can. Especially if you have clients waiting for you for their house to work, and they're putting the pressure on you. Okay, let's see. Does it still work? Actually, it doesn't. The state is what's messing this up, because it's working like a toggle. Interesting. See, that was an error on my part, I have to say. So it probably works best without the context at all, without the state. Very interesting. So if we remove the state, or just have the state internal, so we can do it that way. We'll just leave it the way it was. And probably you can take all this out, because it may work just on the button press. It's not content, it's context, which means it's internal, setting the memory internal to this function node. See, the minute I changed it to flow, the two nodes knew what each other was doing, and they became the same, in essence. Okay, as you can see, I changed it. It has the blue bubble again. Let's deploy, so that everything, what you see is what's working. Because if you have blue bubbles, it's not going to work the way you think it works until you deploy it. Okay, let's try it again. Yeah, it's working again. Back to work. Okay. What is this? This is the change node. Here we go. A change node does 4 things, or can do 4 things. You tend to use change and set, but you can do any one of these 4 things: set, change, delete, move. What does that mean? Okay, so the message comes in. It's a message object, right? Here's a message object. There's a topic, payload. These 2 are always present. And if you add anything else, then it would be something else. But usually there's no true big reason, unless you're, having some different things. No real reason to do it. To have it, to add more. Most of the time, you just use message.payload, and that's it. So a message comes in. On. What does on mean? Well, in this case, on means true. Instead of a 1 and a 0 like we're getting from the pin, an equivalent is true and false. So here, we're sending a true. True is going here. Message.payload. True. Okay, so it comes in. Object comes in. What are we looking at? Ooh, message.payload. If it's true, make it false. So now it changes. Now, message.payload is false. And that's how it's going to go out of this node. False. So it's going to flip-flop it. It was true, now you're false. Right? We're also setting the flow.state. Remember, that's the variable we made. So false, to keep these in track. That's false. And just for the heck of it, we can do message.state, set it to flow.state. So that's also false. So we could have set it to false, or we just set it to whatever flow.state is. Since it's changed here, it's false. It's going to be changed here. So what do we have? Message.payload is going to be false because it was true. Flow.state is also going to be false to track with that. That's the variable we're using to track the state. And then we decided, hey, let's make a property in message that also tracks the state. And it comes out of that. We hit done. And it goes out of toggle message. And that sends the complete message object. Let's close that. Let's close that. So if we hit it, state equals false. Right? And where's that coming from? Our out of toggle state. Right here. Remember, it goes here and it also goes here. So both of them, we get both. We get a message if you want it. We get the message object. And in this case, also, why not? Let's get the state from the flow. What's this, you ask? Well, this is a little more advanced than you would ever see in a beginning. But if you just look at it, you can use it, because one of the hardest things to do in any kind of programming is really get an idea of what the state is of the variables, and not to state the variable that we had, but just what the value of the variables are and then at any time. So what this does, it uses something called JSONata, which is a kind of a programming query language for JSON, which is a whole other thing, which is a way of describing data. I don't want to get ahead of it all. But in this case, we're just using this state equals, okay, this is a string, nothing here that we haven't seen before if you've done any kind of programming, and concatenation, this, the $, which is a function, and a function called flow context, which means the flow context of called state, which is the memory that we were talking about. So it's the flow one, not the context one, not the global one, of state. So we're just trying to say state equals flow context of state. If there was another variable we wanted to chase down, we can do the same kind of thing if we're keeping it in memory. We just put the name, just keep this all the same, change state equals to, my name equals, and then put, name over here. Whatever you did, you could just copy this out and paste it, not know much about it, and it will work. If you don't want to use it, then just don't look at it. Don't worry about it if it's too much. So we went through flow.get, flow.set. Our debugging options, you have message. You can use a message. You could use the state to debug items. So we're doing pretty good. So in this case here is the opposite, toggle on. So here we get an off, which is false. So it sends a false to the change node. The change node says, oh, if it's a false, I see a false, looking for a false, set it to true. Flow.state, which is our variable that is going in memory, memorizing where we are with either false or true, 1 or 0. We're setting that to true. And then we're taking our newly created property of message, and we're setting that to flow.state, which we just set above. So that would be set to true, which we could do that directly. We don't have to do it that way. Just did it that way to to try it. Okay, and done. So when we click on this one, what do we get? State equals true. That comes out of toggle state, which is this one. This is the JSON. State equals whatever is in the flow memory of state. This one over here, because they're cross-connected, they're connected to the top and the bottom, so you get it both ways, spits out the message object. The object has its classic topic, classic payload, and the state. So the payload and the state, as you know, are tracking. They're both true. Clear that out. We'll try that one. Now, the state equals false. That's your JSON that you can copy and paste and just reuse. Here we have our message object. Every message object has an ID. Everyone has the topic. Everyone has the payload. But we created the state. And the payload and the state should be the same. And we did this just for showing. This makes it easy. Because it's easier to see it here as an object. And you don't have to have this extra string. So if we didn't have, let's say we like, okay, that's too many things. We want to just use the object. We can disable the debug and do it again. And all you get is the out of toggle message, which is the one above, which is the one that's the only one activated. As you can see, it's the only one that's green. And then when we open the object, we see that true is true, is true, is true. We hit off. That makes true, because it's the opposite. We do on, and you just heard the relay click. It goes off. So, as you can see, off, on, and if you use the switch, you see they stay in line because of the state. See, that's not going to work, but that'll work. And that's that. We also have this inject node, which shows what's in the eject node. Let's say a true. So we send the true over to toggle, but you could send anything. And what does it do? All it sends is a true. So it's already set to true, which is a 1. And that's that. Okay, so I think we've gotten through everything here. Debug actions, switch, whatever. And that's pretty much how it works. Okay, bye now. This is an example of the toggle. As you see, toggle on, press the button, toggle off. And now an example of the momentary, in reverse actually. So press, it goes off. Press off, and then let go is on. And that's usually just set up with the software.